Idea about physics electron. First of all, we learned about degenerate semiconductor. If I heavily doping to semiconductor, then we mark that n plus doping. Then ionization donor state like very density create. So this line is not discrete or like continuous. So new conduction band created. Then one problem is happened. Symmetrically, Fermi level is higher than conduction band, so Fermi level and conduction band middle electron has fooled. So the situation is not exactly because this material is more like semiconductor, is more like conduction property. So this semiconductor we called degenerate semiconductor. And next we can now the current flow in homogeneous semiconductor. One mobile carrier is moving to another place, but carriers nearby exist another trap, lattice or trap. So electron doesn't go straight to another place that hit the other place. So we called about collision or scattering. So we drive to this mathematical equation. Velocity Vt is mobility E. This E is electric field, and mobility is mobility. We can mark that. So electron velocity is minus mobility minus mu E, and whole velocity is mu E. This minus sign is electron move to another direction to electric field. So we drive to mathematical law P is mv and ft. So we drive to finally V is QE per m. So we concentration this mathematical law. Current density is conductivity E. So drift current is electron current drift plus Hall drift current. And we can drive to this mathematical law is current density is Q and mu E. So electron current density is Q and electron mu E plus Q and Hall's mobility E. And next carrier scattering. If I dove to n-type, so n-type, then fixed charge give 2 electron, and fixed charge is the plus. So here is go straight to another place, and electron moves to fixed charge direct. And p time is fixed charge is minus sign, so whole moves to fixed charge direct and electron moves to another place. We heard about Coulomb scattering. So if I doping a lot of doping, then mobile carrier is higher and impurity scattering higher and velocity lower. And we learned about scattering's type. First type is lattice phonoscattering. Origin electron is 0 Kelvin. Origin electron is frozen when 0 Kelvin, but outside gives to phonon to electron. Then electron's degree is higher and collision higher and mobility is down. And next scattering type is surface lossless scattering. Material has lossless to surface, so crystalline is broken to crystalline and exists to trap state. So Martinez rule is concentration the change to lower velocity. So we can mark that graph. Green line is impurity scattering and yellow line is phonoscattering. To Martinez rule, mobility is follow the impurity scattering higher and follow the phonoscattering to mobility is lower. So if more doping, then impurity scattering is lower and mobility is lower because that line is low direct to phonoscattering. So we know the mobility is doesn't infinity increasing. So we call the velocity saturation. And next we learned about diffusion current. This line Y sign is carrier concentration. And we pick up that point that we mark that point is x0 and that point is x0 minus L because this length is L and next point is x0 plus L. So we can drive to Maslow the 1 part 2 Q and x0 minus L VTH. This VTH is summer velocity. So diffusion current is 2 current density minus 1 current density. So blah blah blah. We can drive the cube. Summer equation R dn per dx. VTH R is diffusion coefficient and Q dn dx is diffusion current density. Diffusion coefficient, we can mark that D is VTHL. Diffusion coefficient mean is how electrons, how much best and how much fur. So carrier is moving to diffusion electron field first. So electron moves through diffusion. The materials has VTH. this mean is diffusion coefficient. So we can derive the light mathematical law. And so we know the carrier constant if appear the carrier concentration degenerates, then diffusion current exists. So and we derive the diffusion coefficient is kBT per Q mu. So we know the diffusion coefficient and mobility is same character. So if mobility is higher, then diffusion coefficient is higher too. Then we heard about that mathematical law to Einstein relation. And finally, we can derive to current density is total. Current density total is n drift current density, electron drift current density plus Hall drift current density plus n diffusion current density, electron plus Hall diffusion current density. And this metric, yes. So we can know the drift current source is electric field and diffusion current source is carrier concentration gradient. And next, we'll learn about generation. Generation's mean is a process of creating electron hole pair or exciting an electron from valence band to conduction band. But we can know the inside the light is Ha mu is more than higher than valence energy gap. So if light energy is more than higher than energy gap, then valence band and carrier moves to conduction band. We could like that band-to-band generation. And recombination's mean is a process by which an electron from conduction band is moving to valence band. If carrier moving conduction band to valence band, carrier will lead to phonon or photon energy. But if I dove to boron or p-type, then acceptor state create the acceptor state. So mobile carrier is moves to directly valence band to move not directly the valence band to conduction band. Then first valence band move valence band to acceptor state, and then move acceptor state to conduction band. And if I adopt to phosphorus for n-type, and donor state is created, so mobile carrier, first of all, mobile carrier is moves conduction band to donor state, and then move donor state and valence band. We heard about like that two-step process or trap-assisted generation. So we heard about like for light, generations is absorption and recombination is emission process. And if I appear the direct band gap situation, then mobile carrier is moving to valence band to conduction band is directly. But in direct band gap situation, mobile carrier doesn't move valence band to conduction band. So mobile carrier gives to more the energy energy gap. So we can derive the mass flow is N0 plus delta N. Delta N is excess carrier concentration, and N0 is initial carrier concentration. And next we can learn about continuity equation. This box is p-type silicon. So if current flow that box, and then we can derive to Jp x plus delta x. So we can derive the equation like that. So if current flow that box, then current is changed, then carrier is changed too. So if carriers change to mount change, then carrier concentration gradation flow to diffusion current. And then minority carrier lifetime and diffusion length. If p-type has a lot of initial hole, so generation or recombination have to, then we can't directly know the initial hole. So more effectively, we look the minority carrier is electron. So p-type we can see the electron, and n-type we can see the hole, the more effectively. So if I uniformly doped p-type semiconductor, then this point I have many light escape. Then p-type is n electron concentration is more higher and exponentially lower the current carrier concentration. So that happened, we heard about diffusion current a bit ago. For mathematical law, 37% is diffusion length. And equilibrium means is summer equilibrium. Summer equilibrium happen, then Fermi level is constant. So Fermi level is constant, then carrier doesn't flowing. And non-equilibrium is not summer equilibrium. So happened quasi-Fermi level. Quasi-Fermi levels mean is electrons Fermi level and whole Fermi level is not symmetrically like that. The blue line is whole Fermi level and red line is electron Fermi level. So we can derive the mathematical law, and total current by electron is blah blah blah. This mathematical law. And graded doping. If I non-uniform doping, then more doping part region is have more electron, and low doping part is has lower carrier concentration. So happen the electric field. So we can know the all part is neutral, but if I look the local part, then relations is left region is minus sign, minus it, and right direct is plus. So we can draw the diagram like that. Fermi level is constant and valence band is conduction band is parallel. Okay, thank you.